Hello everyone. Good evening and welcome to the session. So we'll
Good
wait
evening.
for a couple of minutes. Okay, so we'll then begin. So what is the usual count? Like, can anybody tell me how many people regularly join?
Mm, Approx 25 plus 25 around.
Okay. Okay, great. So then we'll just wait for the count to touch at least 18, 19. Then we'll begin. Okay, so those who have joined, uh, I hope my screen is visible.
Yes, sir.
Yes. So since this is week three, I hope all of you know what to do in Solve with Us kind of sessions. If there are anyone who doesn't know, I would like to explain this real quick. All I want is if you have joined via laptop, open a new tab and type joinpd.com, and then it will ask for a code, and the code is SCJHZA, which is visible on the screen. But if you have joined via mobile, open Chrome, and even in Chrome also you can do the same thing. Uh, Type joinpd.com. It will ask for a code and type this code which is visible on the screen. Okay, so today we are going to solve some problems which will help us to understand
Sir,
the
after
content
SCJ,
better.
we have to give space.
Sorry, no need. You just type SCJHZA. It will automatically. Okay, so what I'm saying is, so today I have some 6, 7 problems. After solving those problems, it will give us more clarity or understanding on week 3 contents, as well as it will also help us uh, submit or solve graded assignment questions. So it will help us in both ways. Okay, so we have another session on week 3 on Tuesday too. That session is just an open session where you can come and discuss your final doubts that you have related to week 3. Okay, so before we begin, I'll just introduce myself. I think this is the very first session I'm taking for Stats 1. So my name is Srikanth Venkateshan and I am one of the course instructors for Statistics course. And I have been working with IIT MBS for almost 5 years by now. And I have taken multiple courses. I started with math and then I have moved across many courses. And now I came back to Stats after a very long time. So if at all something goes wrong, maybe you guys have to help me out. So I will teach you and you teach me, and together we will learn and improve our knowledge in statistics. All right, okay. So 11 people joined, and I think 11 people, 12 people joined in this joinpd.com. I want all of you to those who have joined this Zoom link, all of you to participate in this joinpd.com and in this exercise, small exercise. Okay, so even though your answers are wrong, do not worry. Okay. Uh, yeah, so let's begin. Friday, I think we have summarized most of the contents, right? So related to week 3. So we'll straight away jump to the very first problem.
Srikanth, sir, sorry to interrupt.
Yes,
Can you please share the join PD link again?
in Zoom. Yeah, good.
Yeah,
I'll just put it in the chat. Okay.
yeah.
So it's joinpd.com and the code is SCJHZA. ZA. Okay, so I have
Thank you.
put the details in the chat. You can also see it on the right top right. Right, so the code is visible on the top right. Okay. Okay. All right. So were you guys able to enter your answers?
No,
No,
sir.
sir.
No.
No, sir.
No, sir.
Okay, something is wrong. Just give me a minute. I'm not able to see that. Just give me a minute, okay? Yeah, I think something is missing. Just give me 2 minutes, okay? Yeah, I will work on this. Meanwhile, if you guys have any doubts or discussions, you can put it in the chat. I'll take it at the end, okay? So if you want me to discuss anything related to week 3 or week 2 or anything related to statistics or anything related to your life, you can put it. Okay, so just give me a minute. All right, so I think the code might change. So all of you have to shift to different pair deck. Uh, I'll share the screen and tell you the code. You can all come out of that pair deck slides. All right. So this is the new code. Let me paste it in the chat also. New and final code. I hope so. It is NPH and CXT. Okay, so I can see the approx 28 students here in Zoom. I expect all of you to participate in this joinpd.com, if not at least 90% of you in this. Okay, so yeah,
Excuse me, sir.
hello. Yeah,
So what will you discuss? I joined
today,
late, sir. Yeah.
sorry. Okay, so we are going to solve problems. So I'll give you some time to solve a problem. And after you have solved it, we will discuss a solution and move on to the next problem. So we'll do some
Okay.
7, 8 problems today, which will help us to understand the week 3 concepts better, as well as it will help us to answer graded assignment questions of week 3. So that's all we are going to do today. That's my agenda basically. So if I am able to finish this in maybe 1.5 hours, maybe the last half an hour, I will just open it as open discussion where you can raise any queries or concerns or
So how can I
questions.
access? Sir, how can I access the recording session of this?
Those things I think you will get it later, no? YouTube, we are streaming this live already on YouTube, and the
All right.
YouTube
All right.
links will be provided to you.
Yeah. Okay, sir. Thank you so much.
Okay, yeah. All right. So I think now everybody able to enter your answers in peer deck, I guess. So I can see some
Yes,
9
sir.
responses already
Yes.
people have given. So this is basically what kind of data? Week 3 we dealt with.
Numerical data.
So numerical data, correct. So there are 4 numbers given to you, and the frequencies of all 4 numbers are also given to us. All we were asked to find is the mean of the data, right? So very trivial. So we are starting with very easy problem, and hopefully by now everybody should have solved this. But let me give you one more minute. And okay, so let me tell you, among the 4 courses in the qualifier, in my these many years of experience, the syllabus that is there in Stats 1 and the paper of Stats 1 is the most easiest compared to all 4 courses, right? So comparing English 1, CT, Math 1 and Stats 1. So the syllabus, I mean the concepts that were dealt in the first 4 weeks, these things are fairly straightforward. There is no trickiness or any difficulties. Once if you understand the concept clearly, and if you have solved enough number of problems, so I'm not saying too many number of problems, enough number of problems. So each concept, some 5, 6 variations is sufficient. So all you have to do is activity, practice and grade it. You don't have to pick a textbook for this and sit on solving problems. So these concepts are not that difficult. And I will give justification to all my statements very soon. All right, so we'll see the responses that you guys gave. Okay, so I see 5.52 many of you gave, but okay, so there is one guy who has given his hall ticket, I guess. So, or one of his phone numbers. Is it a phone number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So this is not we asked for. Okay. So all we asked was to find the mean, and here is how the solution should go. So if you know this, if you don't know the solution yet, this is how you should solve. First, tabulate the given information. Right. So you write all the numbers that are given, which are excise, and their corresponding frequencies. And frequencies are basically in the data set that number is repeated that many times, right? So if you are confused about frequencies, you write 2 8 times. So 2 is there 8 times in your data. Then 6 is there 4 times. 7 6 times and 9 5 times. So there are a total of 8 plus 4 plus 6 plus 5 data points, out of which all of them are either 2 or 6 or 7 or 9. So for mean, what you have to do? All you have to do is sum of the total observations divided by total number of observations that you have. Right? So if you use that formula, you can get the mean of the given data. Right? So it will come out to be 5.52, and most of you are correct. Okay. So any doubts in this?
No, sir.
No, right? Okay.
No, sir.
Great. Let's slightly complicate our lives. Okay. So instead of fixed numbers, what we did is we have given the frequencies which are unknown frequencies now. So there is some relation with x, and there are 4 numbers again. It is 4, 5, 7, 8. But frequencies are x minus 3, x and x plus 3 and x, where x is unknown to us. But what information do we have is their mean. So mean of the given data is given to be 6.225. Now what you have to do is you have to find the missing value, which is x. All right, so I'll give you maybe 4 minutes. By 6:20 you can discuss. And see, as I said, these are mathematics and statistics are kind of numbers involved, and you have to perform some operations and compute. So you should always run behind finding your x. I mean, the variable x, not your x. Okay, so it needs a pen and a paper to solve. Okay, so I suggest everybody to have a notebook or a paper along with pen. And whenever you attend statistics or mathematics kind of courses, please do follow this. Okay. So if you don't put pen and paper, it's very hard to understand these courses. Yeah, so last 1 minute. Okay, so don't put your answers in chat, no? So it will ruin the fun of the people who is trying to solve it. This is for Idika Hakkinapalli. Okay, so if you want to answer, please to join this joinpd.com and type code NPHCXT. You can enter your answers there. Okay, and I can also know who has submitted which answer. Okay, so that your answer will be recorded. All right, time's up. Let's see. Okay, okay. So most of you gave 10 uh, and again I got some minus 10, 6.97, 0.1156 and again the phone number. I'm not sure. Do you want your number to be gone and reach to many people and to get famous or what? Okay, anyway, since most of you gave answer as 10, I think it would be the answer. Let's see. Let's walk through the solution real quick. So the same thing. Instead of first question, we were asked to find the mean. But here, mean is given to us. But there is some missing number that is not given in the information, which is x. So the same solution that we follow, we will first tabulate the given information. The numbers or the data points are 4, 5, 7, 8 with frequencies x minus 3, x plus 3, x. Right. And then you use the same formula that we have used in the first question for the mean. Right. So when you use it, we know x bar now, which is 6.225. We substitute that and we substitute the other values also, all the xi's and fi's. And we will form a nice equation in terms of x. Right. So when you solve this, you will see that the value of x is 10. Right. And if you want to validate your answer, just substitute 10 in place of x and compute the mean and see whether you are getting 6.225 or not. All right. So let's move. So question 3 has some subparts. So question 3, instead of directly going to question 3, we have some prelude, like it's like heads up kind of question. So we'll prepare ourselves to solve question number 3. So this is how the question is. The mean and population standard deviation of a data set containing 5 observations are 10 and 6 respectively. However, it was later discovered that one of the observations recorded as 6 was incorrectly noted and should have been 1. Okay, understood? So there are 5 observations. Out of the 5 observations, one observation is wrongly recorded. The actual correct recording should be 1, but it was recorded as 6. Okay, so what is the mean of the original data set? So that means the correct data set. Okay, so the mean of the wrong data set was 10. What is the mean of the correct data set? Okay, I hope everybody understood the question. If not, please do ask me. Okay, so don't just sit silent and wait for me to reveal the answer. Okay, I hope everybody understood the question. All right, so I will give some, again, 4 minutes or so. Okay, so 6:28 we will start discussing the solution.
Sir, sir,
Yes.
sir, I have a doubt.
Hmm.
What is the mean? 10 or 6?
10.
Okay.
So the
Thank you,
mean
sir.
and population standard deviations are 10 and 6 respectively. So mean is 10, population standard deviation is 6.
Okay.
The original mean was 10, right, sir?
Like the wrongly given data's mean was 10.
Okay.
Yeah. All right. So I see there are 12 responses. Are there anyone who is still trying? Do you need one more minute to solve, or you guys are happy with the time that you got?
Sir, just submitted.
Sorry?
We are happy with the time.
Sir, I just submitted.
Submitted. Okay. So those who have tried have submitted, and those who have given up, right? Oh, 1 minute. Okay. Okay. I will give 1 more minute. Okay. So those who have joined new, you have to open a new tab if you are using the laptop, or if you are using mobile, open Chrome and type joinpd.com. Okay. And then it will ask for a code to join. And the code is visible on the top right, NPHCXT. So you enter that code and there you can submit your answers. Okay, I think I have given enough time. So let's see what answers did you guys give. Okay, so 9 was given by most of you. And I know 11, yeah, 11 is given by 2 people. And I know the reason behind that 11 also. So we'll see. Uh, yeah, I think the answer is 9, because since we don't know the data sets, observations in the data set, let's say x1 to x5. So there are 5 data points, right? So let's say x1 to x5. And it is given that the mean of, sorry, uh, someone trying to speak. Okay, let me continue. So let's say you have 5 data points, x1 to x5, and it is given that the mean is 10. So from that, we can find the sum of the data points, right? So x1 plus x2 plus x3 plus x4 plus x5 will be just the number of observations times the mean, the given mean, which is 5 times 10, which is 50. Right? But this is not the correct sum, because one of the observation has to be 1. Instead, it is recorded as 6. Right? So that means 6 is 5 units greater than 1. So then the sum should reduce by 5 units, right? So if you take x1 to be the wrongly recorded observation, x1 should have been 1. Instead, it is given as 6. So if I correct the data, the sum of the data points will reduce by 5 units. Right? Because instead of 6, I am writing 1. Therefore, the sum will come down to 45 instead of 50. So the sum, the correct sum. So the original data set sum is 45 and the number of data points in the original data set is 5. Therefore, the mean of the original data set will be 45 by 5, which is 9. Now coming to the people who have given 11, they have taken it in the other way around. So they thought it is recorded as 1. Instead, the correct is 6. Right? So then you will see that the sum will be increased by 5 units and it will be 55 by 5, which is 11. So you have to be a little careful when you read the question, right? So that is why I explained the question 2 times. So 6 is the wrongly recorded value. 1 is the correct recording. Okay. Any doubts here?
Sir, I have a question.
Yes.
So in this question, we are assuming that the frequency is one. But what if like there are more than one frequency?
Then we will compute it accordingly, no? Here we said there are only 5 observations, right? Of a data set containing 5 observations. Okay, so only 5 data points, that means. There is no frequencies at all. So, and there is no point of talking about frequencies. There are only 5 data points and x1, if x1 is equals to x2, then the frequency value of that particular thing will go to 2. Right, so we are not worried about the frequencies of the data points. In the question, it is given that there are 5 observations. And even if they are equal or not equal, it doesn't matter. Yeah.
Okay, sir. And
Right?
there is no use of standard deviation, right? It was just
In
for
this question, but this is just a prelude to question 3. But there is part 2 for this also.
okay.
Okay, so which is going to come now.
Okay. Thank you.
Yeah.
So,
Yeah.
so how 45 came?
How? Because
Couldn't-
uh, because out of the 5 observations, only 1 is wrongly recorded. Rest 4 are correct. Right? So,
Right.
and what is the difference or error that we made? Instead of 1, we wrote 6. What is the error here? How much is the error?
5.
With respect to value. So instead of 1, I have taken 6. So the error is 6 minus 1, which is 5, which contributed to the sum. Right? So in order to correct it, I have to erase that 5 or remove that 5, 5, right? Right?
Okay. Okay. Okay.
So the wrong sum was 50. In order to correct it, I have subtracted 5 from the 50 to correct the value.
Okay.
Okay. So that is by 45. All right. Any other doubts? Okay. So before we go to the final part 2 of question 3, let us expand this variance formula a bit. Okay. So we all know population variance is basically 1 by n into summation xi minus x bar whole square. Right. So xi's are data points and x bar is the mean of the data set. Right. So then if you expand the square, you will have xi square plus x bar square. So it's like a minus b whole square formula, right? So if you expand it, you will have xi square plus x bar square minus 2xi into x bar. right? So now you take that 1 by n. Don't take that 1 by n inside as of now. So you are summing from I is equals to 1 to n, right? So then if you take the summation and if you separate the terms, we'll have summation xi square plus summation x bar square. So x bar is independent of I. So therefore this x bar will be, let me annotate and show. Just a second. Okay. So this x bar and this summation is going from I is equals to 1 to n, right? So when you take the summation x bar square n times, you will have nx bar square, right? So you're adding x bar square, x bar square, x bar square, x bar square n times. So you'll have nx bar whole, nx bar square. Then again here also, this x bar is independent of I, 2 is independent of I. So 2 and x bar goes out of the summation. So 2x bar summation xi, right? So next, what we can do is this summation xi is basically n times x bar, right? Because summation xi divided by n is the mean, right? So this summation xi, you can rewrite this as n into x bar. If I just substitute that, I will have minus 2n x bar whole square, because 2 times x bar into n x bar. So 2n x bar into x bar will become x bar square. So this n x bar square minus 2n x bar square will give us minus n x bar square, right? So therefore, this population variance can be rewritten as 1 by n into summation xi square minus x bar square. Okay, so if I take this 1 by n inside, this 1 by n and this n will get cancelled out. So 1 by n into summation xi square minus x bar square. So that is also the population variance. And use this formula in the next coming question. Okay. So the same thing, same information, nothing changed. What is the population variance of the original data set? Original in the sense, the correct data set. Okay, so this requires some effort and you have to compute computationally heavy. So take time and compute it and give you your answers. Okay, so I'll give you 5 minutes. If that is not sufficient, I may give 1 or 2 minutes extra also. Okay, so I hope most of you have noted down this question. I would like to go one slide back once again. Okay, so just all we have to find is the population variance of the original data set. Okay, so those who understood this expansion, please proceed and solve. Let me repeat this once again for all of you. Okay, So we know that the population variance is basically the spread, right? So variance is basically the spread from the mean. So from that, we finally convinced ourselves that the formula turns out to be 1 by n summation xi minus x bar whole square. So you take each data point, subtract it from the mean and square it, and add all of them together divided by n is the population variance. Right, so now this is like a minus b whole square. We know a minus b whole square is a square plus b square minus 2ab. Right, so then you take this summation inside. Inside, I mean you put summation to all three terms separately. So the first term will be summation xi square, which is this. The second term will be summation x bar square. So summation x bar square is basically you are doing summation from I is equals to 1 to I is equals to n, right? So it's like you are adding this x bar square starting from 1 to n. That means x bar square, x bar square, x bar square like this. You are adding it n times. So it will just become n x bar square, right? And then if this summation goes to this term, this is like summation 2xi into x bar. So this 2 and x bar are independent of I. So it can be pulled out of summation. It will just become 2x bar into summation xi. The summation xi is basically, if I divide this by n, that will become mean, right? So because sum of the data points divided by the total number of data points gives me mean. So if I take this n to the right side, I can clearly see that the summation xi is nx bar, right? So I substitute this here. I'll get 2x bar into nx bar. That will become 2n into x bar into x bar will become x bar square. So this nx bar whole square minus 2nx bar whole square will give me minus nx bar. So therefore, this population variance can be rewritten. So it's like just rewriting the population variance in a different way. That's it. 1 by n summation xi square. What does this mean? You square each and every data point and add all of them divided by n. Okay. Minus you square the mean. That's it. Okay. So I hope this is okay. Coming back.
Sir, one question.
Yes.
Sir, for the summation of xi, so it should be x1 plus x2 plus x3 up to that much. So it should be equal to x bar. Why is it equal to n into x bar?
No, summation will not be x bar. No, x bar is mean, right? What is mean?
Oh, yes, sir. That n will be multiplied. Yes.
N will be multiplied. No, the denominator n will go to the right side and it will just become n times x bar,
Yes. Thank you.
right? Okay. Okay. So only 9 people have given their answers. Now, please enter your answers. I have came to this slide. 11, 12. Okay. So I'll give 2 more minutes since this is um computationally heavy. You can take 2 more minutes. So again, for submitting the answers, please open a new tab and click joinpd.com, type joinpd.com, and you can see the top right, the code is visible. Submit that code and you can answer there. All right, so let's see the solution. Okay, so we are going to use the formula that I have just shown now, not the original formula. Since the standard deviation is 6, the population variance is 6 square, which is 36. Right, so that 36, the number of observations are 5, so that means n is 5. The population variance will be 1 by n, which is 1 by 5, summation I is equals to 1 to n xi square minus 5 x bar square. Right, so this population variance that we are going to compute is for the wrongly recorded observations. Okay, so if I substitute and compute the summation xi square, okay, using all the information, I can compute this summation xi square, right? So 36 into 5, you take 1 by 5 to the left side, it will become 36 into 5 plus 5 times 5 into 10 square, which is 5 into 100, which will become 500. So 5 into 36 is 180. 180 plus 500 gives us 680, which is summation xi square, where one of the observation is still 6, right? Not 1. So in order to correct this sum of squares, we have to subtract that 6 square, because I have added 6 square into this. I will remove that and add the correct one. So the correct value is 1. The wrong value is 6. So I will subtract this 6 square from the square terms and then add this one. So the corrected sum of squares will become 680 minus the wrongly recorded observation square. I will subtract it, which is 680 minus 36 plus 1. So 680 minus 36 is 644 plus 1 gives me 645, which is the corrected sum of squares. And from the previous question, we have the corrected mean. Instead of 10, we have to use 9. Once we have this summation xi square and the mean, we can compute the correct population variance. Right, so the correct population variance is 1 by 5 into summation xi square, where I have to substitute the corrected sum of squares, which is 645 minus 5 into 9 square. Right, so 645 minus 5 into 9 square is 81. 5 into 81 is 405. Right, 405, and 645 minus 405 is 240. 240 divided by 5 will give us 48. Okay, so I hope all of you have given, most of you have given 48. Yeah, so most of you have given 48 and some of you have given different values also. Okay.
Sir,
Okay,
can
so
you
there are two people
explain
who gave
again?
324. Sorry.
Sir, can you explain again how? Okay.
Okay, so the population variance formula that we are going to use is the bottom one, not the top one. Okay, is this clear? In the coming question, the population variance that we are going to use is this 1 by n into summation xi square minus n into x bar square. Okay, where x bar
Yes,
is
sir.
the mean, x bar is the mean, xi square is the square of each data point. Okay, so here in the question, standard deviation is given to us for the wrongly recorded data point, which is 6. If standard deviation is 6, population variance will be 36. right? So 6 square is 36. And from the formula that just we derived, which is 1 by 5 into summation xi square minus 5 times x bar square. We know x bar, that is also given in the problem, which is 10, in the data, which is 10. From there, I can find summation xi square, right? If you compute the summation xi square, you will see that it is 680. This summation xi square is 680 when one of the data point is recorded as 6. Now we are going to correct that. Instead of 6, we are going to put 1 and compute the population variance. So that is the question. And that is what we have to find. So the summation xi square is wrongly recorded one. So in order to correct it, the wrongly recorded value 6. So 6 square, I will subtract from this summation. And the correct recording is 1. So I have to add that 1 square. So the corrected sum will be 680 minus 6 square and adding plus 1 square, because I am removing the wrongly recorded one and then adding the correctly recorded one. Okay, so that corrected sum of squares, which is summation xi square, is 645. And we
Sir,
have also corrected our mean in the previous problem. Yes.
Sir, in the corrected sum squares, instead of removing a 6 square and adding 1 square, can we directly do 5 square? Like,
No, it's not the 5 square, no, 6. See, xi, what is xi square? You square each and every data point. And what is summation xi square? You square each and every data point and add all of them, right?
yes, sir.
So earlier it was 6 and you squared it and you added it with all other 4 data points, and that sum is 680. Now you want to correct it. So what will be the best way to correct it? If you do subtract 5 square, is 6 square minus 1 square is 5 square?
No.
Not, right?
No.
So you cannot do it. So what we are going to do is, okay, the total sum is 680, but one of it observation we recorded it was 6, which is contributing 36 to the square, right? Summation square. So okay, you remove that 36 first. Then what is the corrected value, which is 1? So if I am using one data point as 1, if I just square it and add it to the sum, it will give me the corrected sum, right?
Yeah.
Is this
Okay. Yeah, got it. Thank you.
okay? So once you correct this corrected sum of squares and corrected mean from the previous question, again use the same formula. For corrected population variance, you just use 1 by n into summation xi square minus n into x bar square, right? But this time summation xi square is corrected. It's not 680, it is 645. Even x bar is also corrected. It's not 10, it is 9. Okay?
Yes, sir.
No, not okay.
Okay, sir.
Okay. Okay, so the next coming problems is all
Excuse
interconnected.
me, sir.
Yes.
Sir, I tried to do this question in some other way, and I got the wrong answer, but I am not able to figure out where exactly I made the mistake. Can you please tell me if I tell the way that I did it?
Yeah, proceed.
Sir, since they've given the standard deviation of population to be 6, I took that and I wrote the formula for the mistaken one itself. And using that, I found it out. I found the sum of squares of the the deviations from the mean. And
Okay.
I got that to be 180. And since now I want to find out the population variations. So in the square of the deviation from the mean that I got, I subtracted like 6 minus 10 the whole square, because the 6 is the observation that was given read as wrong, right? So minus 6 minus 10 the whole square, and then I added 1 minus 9 the whole square.
So what you are doing is you are taking mean x bar as 10 at one place and 9 at another place.
A 9, I'm taking it for 1 when I'm
Ah,
adding it to the square.
but the thing is, when you are taking mean should be the same or consistent for all the data points,
Okay, okay.
right? So this
Yes,
x
sir.
bar is basically x1 plus x2 plus x3 plus x4 plus
Hmm.
x5 by 5. If
Hmm.
you are changing any of the data point value, this mean will change accordingly. And that changed mean you have to use for all other data points also. So you
Okay,
cannot
okay,
separately take 9 for just for one and use 10 for all other.
okay.
Right?
So if
So
I have to get the right answer in this method, what
mm,
should be the correction that I need to do?
okay, so the same thing. So instead of the bottom formula, you are using the top formula, right? So this 1 by n summation xi
Yes,
minus
sir.
x bar whole square,
Yes, sir.
right?
Yes, sir.
So
Yeah.
what you do is you take each and every data point.
Hmm.
There, what happens is this x2 minus x bar and x3 minus x bar is slightly difficult to compute, right? So this x bar is changing. So why
Hmm.
I am using the bottom one is because the data points and x bar will be separated out
Okay.
in the bottom one. Whereas if
Yes.
you use the top formula, the data point and x bar are interlinked by this minus sign, right?
Hmm.
So
Hmm.
it's very hard to compute. So that is why I'm using this for the bottom formula to get to the
Okay.
solution.
In the top formula, we don't know the individual observation, so we
Individual
cannot take
observation values
different
and we
means.
cannot take it directly.
Yeah, yeah. Okay, sir. I got the mistake. Like I took two different mean and it was wrong. I
Yes.
shouldn't have done that.
Yes.
Okay, sir. Thank you.
Okay. All right. So the next coming questions all are interconnected and all are connected to the stem plot. Okay. So stem and leaf. And we'll see how to solve this. Okay. So now the data is represented using one of the beautiful ways of representing, which is stem leaf plot. Right. And this stem leaf plot I can use when the data points are very less. Right. So if you have only 10 observations, 20 observations, which are slightly closer to each other. Okay. So then instead of histograms or any other ways of representing, stem plot is the best way to represent because you can see all the observations at the same place, and also it is well separated. It looks like you can see which bin has highest values. Everything is very nice and clean in stem plot. Okay, and this stem plot has many negatives also. If the data points are very large, maybe 50 points or 100 points, then stem plots are not the proper way to represent. Then you have to go to histograms. Okay, so let's see the problems, sequence of problems related to stem and leaf, and correspondingly we'll also see this IQR, interquartile range, right? So we should know how to compute the median, how to compute the first quartile, how to compute the third quartile, and how to compute the interquartile range and also the range of the data set, right? So all these things will do one after another. Okay, so here there are 9 data points, right? I hope everybody know how to read the stem plots, right? It is also given there.
Yes, sir.
So stem contains all the values of the number except the last, the units digit, right? So and leaf will contain the unit digit. All right, so that's how stem plot is read. So here the data points are 12, 18, 20, 25, 25, 25, and there is no data point between 30 to 40. And then we have 45, 47, 49. That's how you should read the stem plot. Okay, and it represents the marks obtained by students in a test out of 50 marks. All you have to do is to compute the first quartile, so the 25 percentile. Okay, so okay, I already got 11 responses. I think this is just the prelude one, right? So it's kind of heads up for the difficult problem that is going to come for question 4. Okay, so 2 more minutes and we will proceed to the next prelude. All right, so let's see. Okay, so 18 and 20, even 19 also is significantly given. Okay, so let's see 18, 19 and 20. Let's see how to proceed. Okay, so firstly, write down the observations in the order, right? So we have to always write them in the order when you are computing median or this Q1, Q2, Q3. Q2 is basically the median. Uh, Anything related to range or interquartile range. It's always good practice to write the observations in order. Okay, in the ascending order. So when you write down the observations, it is like 12, 18, 20, 25, 25, 25, 45, 47, 49. So the total number of observations are 9, right? And to calculate the 25th percentile, it is basically 0.25. P value is 0.25. So n into p. So all we have to do is if we want to compute the 25th percentile, you multiply n to 0.25. If I want 30th percentile, you multiply n to 0.3. If I want the 10th percentile, so whichever percentile I want, I just multiply its fraction value to the value of n. Right? So if I compute np, which is 9 into 0.25, will give me 9 into 1 by 4. which is basically 2.25. So if it is an
Sir,
integer,
why
sorry,
we take greater value, not take closest value?
no, it's not closest, it's the greatest. That is what we are
Why,
going to
sir?
discuss.
Why we
Why?
take
Why? Because
great?
2.25 is basically two observations are crossed and you are moving towards the third observation. So if you
Yes,
take
sir.
second observation, it is not the 25 percentile, it is lesser than the 25 percentile. Right?
Sir,
We
third
want to
observation is also not a 20.
sorry.
Sir, third value is not also a 25%. It is also greater than 25%.
It is greater than 25 percentile, but the point here is since these are discrete values in the data points, if you take 18, which turns out to be like something like the very second value, right? Second observation, which will give us like some 20th percentile or 18th or anywhere near to 20th percentile is what I think. So if you are showing the 20th percentile as 25th percentile, then the interquartile range which we are going to do within few seconds, it will change. And if that changes, then the outliers might come into the data points, which will change the whole story of the data, which might change the whole story of the data. So it's basically you want to lie as close to the mean, firstly, and yeah, so that is why we will take which is greater than 25 percentile. Even for 50th percentile also, it should be minimum of 50th percentile. You got it? No?
Yes, sir. I got it.
So it is like that. So if this NP is integer, then we will take that observation directly. If it is not integer, then we will take the next observation. Okay. So that is why 2.25 next observation is third observation. And if you put the data points in ascending order, the third observation is 20. Okay. So, and we will follow the same thing for other quartiles also. Okay.
Yes, sir, don't we take the 3 mark?
Sorry.
Why don't we take the mark 3?
There is no. So it's not 3. It's stem is given to be 3 and there are no leaves, right? So that means there are no values at all.
But out of 50, 3 mark, so it
Ah,
is not taken.
3 mark is possible, but 3 marks is shown as 0 in the stem and 3 in the leaf. That is 3 marks. So it will come here. Above 1, there will be 0. And here, there will be 3. That will represent 3 marks out of 50. Here, the stem is given to be 3 and there are no data points at all. There is no leaf. Right? So leaf should always be there for a data point. Okay.
So if there is no leaf, we don't consider that stem.
We don't consider that stem. So it's basically there are no values that are starting from 3. Like 31, 32, 33, 34, 32, 40, 39. There are no values at all. The next value is 45. Okay, so that is what this stem plot
Okay, sir.
says. Yeah.
Thank you.
Okay, so now we have to calculate the median and it's like 50th percentile. But the catch here is don't count it for 50 marks. You convert it to 10 marks, 10 points. Okay, so now 50 marks, if 50 marks is 10, then you calculate the median and you might get some median value. You write that median value by converting it into 10 points, within 10 points. Okay.
Sir, can you repeat again?
Okay. So the total marks is 50, right? When you compute the median, you might get something like 27 or 28 or some value. So that median value is out of 50. But you have to enter the value such that you convert that 50 to 10 points. Then correspondingly, what is 27? So if 50 is 10, what is 27 is the question. And whatever you get, that will be the answer. Is this
Okay, sir.
okay?
Yes.
Okay, so I think calculating median is very easy, but this conversion takes a minute more. Maybe by 7:15 we will discuss.
Sir, what is the mean of 10 points here?
So the meaning is, see, these are marks out of 50, right? Given.
Yes, sir.
But what if the total marks are converted to 10? So if 50 becomes 10, what will 12 become? Divided by 5, right? So if total marks 50 becomes 10, 25 becomes 25 becomes 5, right? 10 becomes 2,
Yes, sir. Yes, sir.
like that. So every observation is converted or divided by 5. Every observation is divided by 5. Then compute the median. I hope I have given enough things. Now you can compute easily. So converting every observation to 10 points mean since the total marks is 50, now 50 becomes 10. So that means every observation is divided by 5. You divide every observation by 5 and then calculate the median. Okay. So I think now we can discuss the solution for this. So you can
Yes,
do
sir.
this in two ways. Sorry. Yeah, you can do this in two ways. Either compute the median of the original data and then convert it with respect to 10 points. Or you convert every data point with respect to 10 points and compute the median. Okay. So the second one is slightly difficult because since there are 9 observations, I have to divide all the 9 observations by 5 and then compute the median of it. It is basically like you are scaling. You are multiplying a constant to each and every data point and computing the median. Okay. So first compute the median. Since there are 9 observations, so the number of observations are odd. Therefore, n plus 1 by 2 will be the median, right? So 9 plus 1 by 2, which is the fifth observation, will be the median. Fifth observation, if you see, it is 25. 25 is the median of original. But now it is converted to 10 points. Now, instead of like maximum value is 50, 25 is the median. If it is converted to 10 points, the median will be half of it, which is 5. So 25 by 50 into 10, which will give us 5. Right, so this 5 is out of 10. But I think some of you would have given 25 also. Okay. Okay, all of you have given 5. Good. Okay. So those who have given 2.5, I think you have taken this to be 100 marks. And this is only 50 marks. All right. So we have computed Q1, we have computed Q2. Now let's also compute Q3. Right. So the same data, 9 data points. We compute Q3 real quick. And then we'll move to prelude 4. By now, some of you would have guessed what is going to come in the next coming questions. If you are smart enough, you can also compute them and be ready. Okay, as of now, this question is about Q3, which is third quartile, which is 75 percentile, right? So all right. So since third quartile is 75th percentile, P is 0.75. We'll do N into P, which is 9 into 0.75, which is 6.75. And again, since 75 percentile is basically 75% of the data should lie below that point, below that data point, right? So that is why we consider the next observation, which is the seventh observation. And the seventh observation, if you just count it, it will be 45. And I think, again, let's see. Yeah, all of you have given 45. Oh, there is 47, 46 also, but okay. So some of you gave 47, which is eighth observation. Might be calculation mistakes, but redo it. You'll see that you'll get NP to be
Excuse me, sir.
6.75. Yes.
I was asking that I have joined now only because there was no Wi-Fi connection due to some network problem. So what are we doing now? And one more thing I want to ask that there is student reaction, how to give that?
Sorry, student?
You are doing some poll type thing, na? Student
Okay,
reaction.
okay, okay. So that you can do by joining joinpd.com. So you just go to that website and
Huh?
type this code NPHCXT,
Okay.
which is visible on the top.
Okay.
And
Which
we were just doing problems. Later, please go through the YouTube streaming,
okay.
YouTube
Which website?
joinpd.com. I think it's available in the chat
Joinpd.com.
also.
Okay, let me see. Thank you so much.
Joinpd.com and code is NPHCXT. Okay, so let's come back. Now, in question 4, we were asked to compute the 5-number summary. What is this 5-number summary?
The minimum quartile 1, 50%, quartile 3, and the maximum
Yes.
thing.
So the minimum value, Q1, Q2, Q3, and the maximum value. Okay, so you should enter. So this is not a number. You enter all 5 numbers by putting commas in between. Okay, we are starting with the minimum value, Q1, Q2, Q3, and the maximum value. And I think we have computed all of them, Q1, Q2, Q3. And we know by from the data also, you can clearly see the minimum value and the maximum value. And this should not take more than a minute. Please enter all your answers real quick. Because just use prelude 1, prelude 2, prelude 3. So all 3 are Q1, Q2, Q3. Right, so yeah, just type this.
Sir, I have a doubt.
Yes.
To find the mode of a numerical data, we should find the data which have occurred most time of frequency, right?
Yes.
Okay. Thank you, sir.
Yeah. So tell me, what is the mode of this data set?
Mode 25.
Yes, 25, correct. All right, so 11 responses only. Let me see. Yeah, 12, 20, 25, 45, 49. Right. So all of you gave correct answers. So the minimum value is 12. The first quartile is coming from the first question, which is 20. Second quartile coming from the second question, 25. Third quartile is 45. And the maximum value is 49. So yeah, all of you are correct. So now comes the final question. Not the final question, pre-final. So what is the interquartile range? Right, so you have all the summary values with you. You have to compute the interquartile range. Okay, so if you know what is interquartile range, again, this also should not take more than a minute because you have the values in your hand. Okay, so take a minute or two and submit your.
Sir, I mistakenly submit wrong answer. Can I edit?
All right. So I think 16 people have submitted it. Interquartile range is basically Q3 minus Q1, right? So we know Q1, we know Q3. Subtract both of them. 45 minus 20 gives us 25. Right? And most of you have given correct answer. And finally, before going to the final problem, so we also have some standard way of identifying outliers. Right? So the left of Q1, the right of Q3. So if they are very far from this Q1 and Q3, to the left and right, they are considered to be outliers. And how far is determined by this very nice formula, which involves Q1 interquartile range, Q3 interquartile range. So we'll say a data point is outlier if it is far from left, to the left of Q1, and if it is lesser than 1.5 times IQR, then it is considered to be an outlier. So the data point, a Q1 minus the data point should be, if the difference is greater than 1.5 times IQR, then that is an outlier. Similarly, if the outlier minus Q3 is greater than 1.5 times IQR, again this also considered to be an outlier. So outliers are like these data points are far from the other data points. And how far is given by this 1.5 times thing. Okay, so the question is how many outliers are there here? Okay, so do it. So the hint is basically you have Q1 with you, you have IQR also, which we have computed just now, right? Also Q3. So just compute this Q1 minus 1.5 times IQR and Q3 plus 1.5 times IQR. You have these two values. Then see, then compare it with the data points. Okay. So the question is how many? You don't have to say what data points are outliers. You just have to give me the count. All right, so time's up. Let's see. Okay, great. So most of you have given the correct answer. So if you compute this Q1 minus 1.5 times the interquartile range is 25. So 20 minus 1.5 times 25 is minus 17.5. Right, and also the other value is Q3 plus 1.5 times IQR. Even that also is like 45 plus 1.5 times into 25, which will give us 82.5. So we have to see, are there any data points which are lesser than minus 17.5 and greater than or greater than 82.5. So if you see the data points, everything is in between 30, 12 to 49, right? So all of them are within the range. Therefore, none of them are outliers. Okay, so if at all there is any outlier, then the value should be greater than 82.5 or lesser than minus 17. Okay, so that these are the problems that I have for today. And if you guys have anything to discuss, we can discuss. All
Sir, I
right.
missed starting questions.
These slides will be shared again, okay, on the portal. So you can take a look at them. Okay.
Okay, sir. Thank you.
Okay. So anything else from anyone?
Thank you, sir.
Okay. All right. So we'll meet Tuesday again. And Tuesday is an open session. So go solve your graded assignments, practice assignments, activity questions, theory related queries, everything. Do all week 3. And please do note down your doubts and come back on Tuesday. We'll have a very nice interactive discussion on Tuesday and we'll wind up week 3 there. Okay. So thanks all for joining and have a great day. Bye.
Thank you, sir.
Yeah. Bye.
Thank you, sir.